This chapter and this book, by the way, is called Modern Chemistry, so a lot of what you'll see, I really like this. I know some people are put off by it, but it gives you a little bit of the history behind ideas. Ideas don't just, like pop out and it's perfect, from the get-go. So that's something in science I really like, the history of science. Probably most of you remember some of my stories from earth science. Okay, things happen because of individuals, and I think that's really important and often lost, that we don't, know the characters that make science what it is today. What are you going to ask, Alice?
Wasn't there like in earth science this guy, I think he was Alfred Wegener, he was like his theory, all the scientists were like, oh my god, your theories are incorrect, and then he was like, oh my god, that's the guy.
Yeah, that's a good example. Okay, so the laws of chemical reactions. The first one is the law of the conservation of mass. Mass is neither created nor destroyed in chemical reactions. The law of definite proportions. The chemical compound contains the same elements in exactly the same proportions by mass, regardless of the size of the sample size or where it came from. So calcium carbonate has that same ratio, whether it came from Las Vegas or whether it was made in, Hong Kong. So calcium carbonate always has the same proportions of elements. And then the law of multiple proportions, if two or more different compounds are composed of the same two elements, then the ratio of the masses of the second element combined with a certain mass of the first element is always a ratio of small whole numbers. That sounds so confusing, but here's what it means. Let me just give you an example, and then you should read the example in the book as well. I think the example in the book is the one I'm going to give, though, which is carbon dioxide and carbon monoxide. Okay, those are two chemical compounds. They have the same two elements, carbon and oxygen. One is carbon monoxide is just CO, and carbon dioxide is CO2. And so if you look at the ratio of the masses, it comes out that the ratio is 1 to 2. Okay, it'll always be small whole number integers. Okay, and you're going to see that a lot in this chapter in chemical reactions. Things are integers, which means typically the math in chemistry is a lot easier than in physics because things tend to happen in whole number ratios, right? I can't have half an atom. Really, the bottom line, you can't have half an atom. I mean, you could now, but not in chemistry, not in chemical reactions. So that's all in the book. These are sort of the founding laws, like Steno's laws, kind of.